Okay, Science 10s, let's do this. We're talking about significant digit rules when we're doing calculations. Now, what I want to stress is that remember that significant digits are a way of expressing how certain you are about a measurement, right? So let's take an example, and I'm going to draw a book, and I really sincerely apologize because I am not good at drawing at all. So I'm going to draw a book here. Some of you might be thinking, how can you be terrible at drawing a book? And you'll see in a second. There we go. So we got some book with a title on it, right? And maybe some picture on it, blah, 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 whatever. So let's take a look at this book. And we're going to ask three groups of students. We're going to ask three groups of students to be able to measure the length of this book. But we're going to separate the task into three different sections. So we're going to get one group to measure from here to here. We're going to get one group to measure from here to here. And we're going to get one group to measure from here to here. Now, that first group, they measure 9.24 centimeters. And what that means is that they measured a 9 and they're certain about it. They measured a 2 and they're certain about it. But they measured a 4 and they had to estimate it. They weren't totally sure. That's a question mark, by the way. So remember, their instrument allows them to measure up to 2 decimal places. Sure, no problem. Now let's take the red group. And they measured and they got 5.1 centimeters. Well, what does that mean, 5.1 centimeters? That means they know that it was between 5 and 6. And they're pretty sure about the next digit, but they're not quite sure. They had to estimate it. Okay, and then the next group, they're sure of their 7, they're sure of their 4, they're sure of their 3, but they're not so sure of their 2. So when we add all these up, when we add up all of these measurements, it's going to give us a very certain number. Now let's try and add this up. Let's do this calculation. So we got 9.24 adding to 5.1 and adding to 7.432 plus blah. Perfect. So let's go ahead and add this up. So nothing plus 2 is 2. 4 plus nothing plus 3 is 7. 2 plus 1 plus 4 is 7. Decimal place. 9 plus 5 is 14. 14 plus 7 is 21. Perfect. Okay, let's see. What digits are we sure about? What digits do we know are significant? Which ones do they actually represent a value? The nothing plus 2. Well, there should be values here. There should be numbers. But we didn't have instruments that were accurate enough or precise enough to be able to measure them. So the something, right? The something plus 2 should probably not be a 2. So we're not sure about that digit at all. The 4 plus something plus 3 is a 7, but we're not sure about that digit at all either. The 2 plus 1 plus 4 is a 7. We're fairly sure. Even though this one was estimated, we're pretty sure about that, okay? We're pretty sure. And then the 9 plus 5 plus 7 is a 21, and we're very certain of those two numbers because the 9, 5, and 7 were measured very precisely. And so, okay, it looks like that the 2, the 1, and then the 7 is where we're having trouble. Anything after the 7, we don't know. It could have been 7.2, it could have been 7.3. We have no idea. We don't even know what these digits were or what they were close to, right? And so what we're doing here is we're trying to round, when we're adding or subtracting, we're trying to round to the least number of decimal places across all of our digits, because that represents the least amount of precision. So the 21.7 should actually be rounded up to 21.8 because the last digit, that last digit, the next digit over is a 5 or a higher. So the actual value of this is 21.8 centimeters. We'll get used to a couple more of these and we'll move on, but we're going to talk about the certainty rule now. The certainty rule expresses how when we multiply or divide something, we're going to round to the lowest number of significant digits. Now remember, the 2 is definitely a 2, but the 3 could have been a 3 or a 4, could have been a 2, something like that. The 3 is a 3, the 5 is a 5, the 5 is a 5, but the 4 is a little bit of uncertainty. So when you multiply this number by this number, you're going to get, when I do this on my calculator, you're going to get 8.1742. Now in here, we're fairly certain about the 8, fairly certain, and we're fairly certain about the 1, but any digit after this, because this number only had 2 digits to begin with, then we can only be certain about these first 2 digits. So should the 8.1 stay as an 8.1 or should it round up? Correct, absolutely. It should round up to be 8.2. Do you see how the two, the adding and subtracting and the multiplying and dividing, they're separate rules, they're different rules. One deals with lowest number of decimal places, one deals with lowest number of significant digits. So let's try this out and let's do some examples. When I take 4.5 and I multiply it by 2.06, I get on my calculator 9.27. But should it stay as 9.27? Let's see. Because we're multiplying and dividing, we're going to use the certainty rule. And we should round to the lowest number of significant digits. Here we've got 2 significant digits. Here we've got 3 significant digits. So we're going to round to 2 significant digits. Should the 9.2 stay as a 9.2? No, because the next digit, we only focus on 1 digit past. We don't care about anything else, anything over here. That next digit, the 7, rounds the 2 up to a 3. So 9.3 is what our answer is going to be. Let's take the next one. Let's multiply 0.062 times 5.4. My calculator tells me that I get 0.3348. Sure, no problem. Well, let's take a look at this. How many significant digits do we see? Well, here is 2 significant digits. What about the other one? What about that first number? Yeah, zeros out in front don't matter. They're not significant. I could put another 0 here and it doesn't change the value or the certainty or the precision of this measurement. So this only has 2 significant digits. So if we take 2 numbers and they each have 2 significant digits, we have to round to 2 significant digits. So we're going to be 0.33. Now, is the next digit over? Is it a 5 or a higher? No, it's not. Some people really want around the 4 up to a 5 because the next digit's an 8. Now that this is a 5, they want to round the 3 up to a 4, but you can't do that. The reason why you can't do that is because you're double rounding. Is 48 closer to 0 or 100? It's closer to 0. So we're going to round this to 3. Okay, moving on. That was the certainty rule. Moving on, addition or subtraction, that's the precision rule. Round to the least number of significant decimal places. 1 decimal place, 4 decimal places. So we got to round to 1 decimal place. It's 25.9325. So here's my decimal place. The next digit over is a 3. I don't round it up. 25.9. Perfect. Next one, addition and subtraction. Precision rule. 13.625 minus 4.03. That's 9.595. So because it's the precision rule, we got to take the least number of decimal places, 2 and 3. So we got 2 decimal places here. So 9.59, should the 9 stay as a 9 or should it round up? The 5, the next digit is a 5, so it's going to round it up. So the 9 gets turned into a 10. So 1 plus 5 is 6. 9.60. Can you see how this is like 59? And when we round 59 up 1 extra digit, it turns into 60. I don't know. Hopefully that makes sense. What I'm going to do is I'm going to pre-populate the rest of the examples, and we're going to run through them pretty quickly, and then I'm going to get you to do some practice examples for me. Okay, I've pre-populated, or I've done all the calculations, and we're just going to run through this pretty quick. Adding or subtracting, so we got to take the least number of decimal places. 2 decimal places, 2 decimal places, 2 decimal, so we know it's going to be 4.4, but what's after the 4? What decimal is after the 4? Well, because we took 2 minus 2, it should be a 0, but the calculator just didn't show up on the calculator because your calculator doesn't give extra 0 decimal places. So when we round this, yeah, it's going to be 4.40. That's 2 decimal places. Multiplication is the certainty rule, so we got to look at the lowest number of significant digits. 2 digits times 2 digits should be 2 digits. This is a problem. How do you round 100 or a 3-digit number to 2 digits? The answer is you have to use something we learned about a couple days ago, and that's scientific notation. Remember that the decimal place here is after that second 0. Well, because the decimal place isn't included in our rounded numbers, we're forced to use scientific notation. So when we turn things into scientific notation, we have to move it so that it's just after the first significant digit. So 1, 2, we're going to move it 2 places. Now we look at our new digits, our 2 significant digits here, and it's 1.0. The second 0 we ignore now, but because we move the decimal place, we have to express it as a power of 10. How many times did we move the decimal place? 1, 2, so we got to go to the power of 2. Let's think back. 1.0 times 10 to the power of 2. This is like 1 times 100, which is 100. Hopefully that kind of makes sense, okay? We're going to get used to scientific notation and significant digits over the course of this unit. So let's take a look at the next one. 4 digits times 4 digits. So we have to use the certainty rule to round to 4 digits. Here's 1, 2, 3, 4. The next digit is a 5, so it'll round up. 4, 6, 7, 4. That's my answer. Here, adding and subtracting is precision. So 2 decimal places and 1 decimal place. Here's my 1 decimal place. The next value is a 1, so it stays the 0 as a 0. Stays the 0 as a 0. Ugh. This is the worst English sentence in the world. Okay, let's try the next one. 37 divided by 0.01, so that's the certainty rule. 2 digits times 1 digit, right? The zeros in front don't count. They're not significant. So we got to round this to 1 digit. How do you round this to 1 digit? You got to move the decimal place over 3 times. So it'll be something times 10 to the 3. And the 3, the next digit is a 7, so we round it up to a 4. Basically what we're saying is the number 3,700, if we could round this to just 1 significant digit, is this 3,700, is it closer to 3,000 or 4,000? It's closer to 4,000. So our best guess, right? Our last digit is always a guess. Our best guess is this is 4,000. But we use scientific notation to show that it's only one significant digit. 9,002 divided by 73, goodness gracious, that's an ugly number. 4 digits divided by 2 digits. So our answer is going to have 2 digits in it, but it doesn't include the decimal, so we gotta move it. We're forced to move it. 1.2 times 10 to the power 2, and we're using the certainty rule. So try and do the practice problems on the next page, upload them to Floop, and please let me know if you have any questions. Okay, I'm here to help. You can email me. You can ask questions during the office hours. Just try and get a hold of me. Let me know how I can help. Have a good break. I'll see you later.